So another property will be candidate key can be more than one. Okay, can be more than one. Okay. Another property is that it has to be a minimal super key. Minimal super key. Okay. So what is the meaning of it? Suppose if A is a candidate key, then AB becomes a super key. Okay. So it is not a candidate key. Now, whenever A is already a candidate key and you add any other attribute to it, it will become a super key. One more thing is that there is misconception among students that candidate key has only one attribute. Okay, so that is not true. Candidate key can have more than one attribute. Suppose AB can also be a candidate key. There is no problem with that. Now, what will be the super key in this case will be A, B, C will be the super key in this case. Okay, so keep this. This is already discussed previously. If you go on through it, what is a candidate key, what is a super key, what is a alternate key, all the things have been discussed. Now we will be moving on forward to how to get the candidate key in case of a given functional dependency. Okay. Now you already know what a functional dependency is. So suppose if I say that A is functionally dependent upon B, it means that the uniqueness part is already satisfied in that. Suppose if I say that 1 is corresponding to 2, it means if in a table, if 1 comes again, it should be corresponding to 2. If it is corresponding to 3, I cannot say that it is a functionally dependent. A is functionally dependent on B. Okay. So the uniqueness constraint is already satisfied in case of a functional dependency. So there is no worry about that. But how do we find out the candidate key? So how it is? Okay, so I'll give you a simple example. Now you have to remember the previous lecture where we have uh, studied the closure property. Okay, so with the help of a closure, I think we can easily find out what is a candidate key. Okay, so I'll tell you just one step further. When you find out the closure, suppose this is a relation given to you: A tends to B, B tends to C, C tends to D, and D tends to. Again, it is a very important lecture, and if you miss this lecture, do not watch it live. It will be very difficult for you to prepare for midterm as well. Okay, so this is one of the most trickiest part you will find in DBMS, okay, or IMS. So if you miss this lecture, if you're watching it again, there may be some doubt, so please ask me. Okay, it's very important part. Okay, so now what how to find a candidate key is that if you take a closure, of any other property like A plus, and it is find if it is able to figure out or it is able to extract out all the relation attributes, that is ABCD, then you can say that A is a candidate key. Okay, very simple. If you see in the previous lecture, I think this one. So we have finded out a closure in some quite a bit of questions. We are able to find all the properties. Okay, so if you're seeing here, A, B, C, D is the table. Now C is able to find out A, B, C, D, E. So you can call C a candidate key. Okay. Similarly, if you take a look at other tables here as well, so it is A, B, C, D, E, F, G. Okay. So any one that is able to find A, B, C, D, E, F, G, I think it is this one, AB plus. Okay, so you can also call AB a candidate key. I think no. I think ABCD. Yeah, CF plus can able to find out. Okay, you can say that CF plus is a candidate key. Any if you take a closure of any attribute, if it is able to extract out the whole table or whole relation, you can directly say it is a candidate key. Okay, so there are some exception, of course. I'll tell you one by one. So to find the candidate key, you have to try out all the possible combinations. Okay. So there will be one length combination, two length combination, three length combination, and four length combination. Okay. So the one length combination will be, you will find A plus, then B plus, then C plus, and then D plus. Two length combination can be, you can find out AB plus AB, BC, CD. Any other one? AD? Yeah, AD can also be there. Any other combination? I think AC is also there. AC, I think one is remaining, that is BD. Okay, so these are all the two combination possible, all the combination possible of two length. Okay, following the relation ABCD. Now, what is the three length combination that are possible? It will be ABC. I can simply figure out ABC, then BCD, and then CDA or ADC or ACD. CDA, only one is remaining here now. It will be ACD. ACD? No, it is already there. So one will be ABD. Okay, one ABD. This will be another combination that is of three length. Okay, four length combination will be only one, that is ABCD. Okay, so now take a look at it. You already know what is a super key. Okay, so I'll tell you that how to what do you say, reduce your effort one by one. But if you want to find a candidate key, you have to try all the combinations that are possible there, all the combinations. Okay, so I'll tell you how to reduce the effort one by one, but this is the best way you can find in any book. If you take in any book or any other internet search, you will find this method. Okay, so that is to take the closure of every possible combination, and then if the closure is able to find out the whole table, then you can say that it is a candidate key. Very simple. Okay, there are few things that I'll tell you that can significantly reduce your effort. Okay, so first one, take the closure of A plus. Now take the closure of A plus, write A here, and what is A extracting? B. B is extracting C. C is extracting D. So ABCD is derived out here. So it means that A is a candidate key now. Okay, so A is a candidate key. It means AB cannot be a candidate key because A is already a candidate key, and if you are adding some attribute to it, it will become a super key. Okay, so wherever there is a, you can delete or discard that part. Okay, so because A is already a candidate key, if you add any attribute to it, it will become a super key. Similarly, find out B plus. B plus will be B is extracting out C, is extracting out D, is extracting out A. Again ABCD is there, so it means B also become a candidate key. Okay, so if B become a candidate key, so BC cannot be a candidate key, it will become a super key. BD cannot be a candidate key, it becomes a super key. BCD cannot be a candidate key, it becomes a super key. ABD cannot be a candidate key, it becomes a super key. ACD is also not a candidate key because A is already a candidate key, so it will begin a superset. This will not be a candidate key, this will not be a candidate key. You're getting my point here, that if you are able to get the smallest one length attribute to be a candidate key, there are so many things that you do not need to figure out. Okay, so I'll tell you one by one also. Now check for C plus. What is a C plus here? C tends to D, D tends to A, and A tends to B. Okay, so again C plus becomes your candidate key. Again you can delete this part, or I think all the parts are deleted now. Oh, now you can check for D plus. Now D plus is D tends to A tends to B, B tends to C. Again, this is also a candidate key. So there are four candidate keys here. Okay. So why the traditional method is to apply or try out all the combinations. First follow for one length, then two length, three length, four length, depending upon the attributes of the table. Okay. So you have to figure out all the combinations, but there are exceptions here. When you are able to find out that, suppose in this case you are able to find out A is a candidate key, now you do not need to try out any combination that is containing A, because if that combination is already containing A, it becomes a super key, not a candidate key. Similarly, B, C, D. Now you will not get any combination of two length, three length, or four length that will contain other than these attributes. So these four attributes will always be there because they are the candidate key. Okay. So till here, if anybody has any doubt, let me know. Now you should try out yourself and tell me that if you are not able to solve it, just let me know. Okay, so when the questions are given in order to find out the candidate key, keep in mind that whenever you are taking a closure, if the closure is able to extract out the whole relationship, then only you can say that it is a candidate key. Keep that in mind, it's a very important point. Now It's a gate question. I think you can easily solve it. Just you have to keep the basic part in mind. Okay. The gate question say that the relation here is A, B, C, D, E, H. Okay. So now the FD that is given to you are A tends to B, BC tends to D, E tends to C, D tends to A. Okay. These are the FD that are given to you. So they are asking about what are the candidate keys on R. Okay, so when the options are given, it becomes very, very simple because you just have to take the closures of the option. Okay, option is A, E, B, E. If both are extracting out the whole table, that you can say that these are candidate keys. A, E, B, E, D, E, C, A, E, H, B, E, H, B, C, H, and D, A, E, H, B, E, H. Okay, don't worry, I will tell you lots and lots of tricks to significantly reduce your effort. Okay, so tell me what will be the answer here. Take your time. Okay, don't just hesitantly or quickly tell me the answer. Take your time and tell me which of this will be the answer. Okay. Okay, anyone tell me the answer here. Okay, so I want your participation in this. Tell me the answer. Anybody, just post it on the chat box if you are too afraid. Okay.
Option D.
C. Okay. Anybody else? Just post it in your chat box if you're not able to do it.
Option D.
Again, it is very important topic. If you miss it, you will not understand anything. Okay. So now again, the method is very, very simple. What you do, you just take the closure. Okay. So when I take the closure of AE plus, what I will get? First of all, I will get AE, then I will get B. Is there BC there? No. Is there E there? Yeah, there is E. Then it will accepting out C. BC is there, so it is D here. I don't think A, B, C, D, E. So AE seems like a key, but it is not because the whole relation is A, B, C, D, E, H. So it is not extracting out H. If you're saying here, AE is not extracting out H, so it cannot be a candidate key. Okay, so if you take a look at it, there is no H in the functional dependency. Okay, So the H should be a part of the key in order that it will be a closure. H should has to be a part of the key in order to that attribute can be included in the closure part. Okay. So similarly, if you're seeing here, there is no H here, you can again delete that part. Okay. So A, E, B, E, D, E is also wrong because it is not containing H. Because from the functional dependency, you cannot get H anywhere because it is not present there. You will only get the H if H is a part of the key. Okay. So we're seeing here there is a H. Yeah, that can be a key. BE is also there, that can be a key, but is this, because both of these are same, so the answer will be around from both C and D. Okay, we already know that we have find it out AE. If I add H here, H will be there, so AEH is definitely the answer. Okay, so AEH is definitely the key, there is no problem with that. Now check for BEH. So first B, E, then H, write it, then E can extract out C, and then BC is there, it can extract out D, D can extract out D. So again, BEH is also a key because it is able to extract out all the combination possible. Now check for BCH. Now write BCH and then check. Uh, from BC you can get a D, from D you can get a A. Any other combination I cannot get a BC, you can get a D. I think one is remaining. Already B is there, BC, D is there. E, I don't get a E here. Okay, yeah, I'm not able to get E from anywhere, so it is not a key here. Okay, so A, B, C, D, E is not there, so BCH cannot be a key, so it is not the answer, but the remaining will be this one. D will be the answer. Okay, so it's very close between C and D, but the answer is D, because BCH is not a key. You already know that. AEH and BEH is a key, so the remaining will be DEH. Okay. So whenever you're solving this question, I will also tell you how to reduce the effort. Okay. Whenever the options are given to you, it becomes very easy to extract out the candidate key. It's not very difficult. Okay, so try out another combination. I'll tell you one more trick to reduce your effort. If you are first you try this question, if you are able to solve it without trick, I think you can understand the concept of it. Okay, so E, F, G, H, I, J, K, L, M, and N. Okay, so these are the FDs that are given to you. Okay, so E comma F is extending to G, F is extending to I comma J, E comma H is extending to KL, and K is extending to M, and L is extending to N. Okay, so they are again asking you what is the key, candidate key. Okay, so the options are already given. Whenever the options are given, your job becomes so much easy. Okay, you just have to take the closure part. E, F, H. If the options are given, not given, you have to try all the combinations. All the combinations. That becomes a little bit difficult. Again, I'll go with both the traditional method and I'll tell you a trick afterwards. Okay. So let me know what will be the answer. I want your participation. Okay. So try to answer this particular option. Okay. Do it. Take your time, but try to solve it. If you're not getting any point, just ask me. Okay. So I'm here. Okay, so only one student is giving the answer. Any other? Okay, B. Okay. Any other? Okay. Now I think B is the correct answer. Okay. So now how you extract it? Again, go with the already given option. You take the closure of it. Okay. So if I take EF plus, I will get EFG. Now what is F? F is there, so I can get IJ from here. Is there EH present? EH is not present, so you cannot get KL. So K is present there? No. L is present there? No. So you cannot get more than that. So that is not the whole table. Again, go for EFH. Okay, so you already know you will get EFH, and then you will get everything that I have extracted out, GIJ. Okay, so now check EF, then G is there, FIJ is there, EH, yeah, EH you can get KL. Okay, so when you get KL, I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. So there are some remaining. So K, from K you can get M. L is also present, so you can get N. So this is 10. So again you are able to extract out all the components that is already available. So our answer will be B. Okay. So you're seeing here. So C is, if you take the closure of C, it will again result in the whole table again. Now, but it is not a candidate key, it is a super key, because EFH is a candidate key, and if you add anything with EFH, it will become a super key. So that is why this question is very much important, to know the difference between the candidate key and a super key. Okay. So again, if anybody has any doubt till now, just let me know. Okay, so I'll tell you a little bit of a trick that can significantly reduce your effort. Okay, so if you're seeing here, everything that is on the right hand side, everything that is present on the right hand side, it is extractable from the left hand side. Okay, so if you're getting my point, everything that is present from the right hand side, it is extractable from the everything that is present on the right hand side is extractable from the left hand side. Okay, so there is no need for it, so you can just okay, so you can just delete these present attributes from the table here. Okay, so what did you do? G is on the right hand side, you delete G here. IJ is on the right hand side, you delete IJ from the relation. KL is on the right hand side, you can delete KL. M is on the right hand side and N is on the right hand side. So the remaining part is EFH. Okay, so what it means is that you cannot get EFH because it is not present in the right hand side. Okay, you cannot get it. There is no way you can get EFH because it is not present in the right hand side. So EFH has to be a part of the key, has to be the part of the key. It's very simple to understand. Okay. Okay, so first try out the combination EFH, then try out other if EFH is able to extract out all the components, then there will be no other candidate key. Why? Because EFH is mandatory. EFH has to be mandatory because EFH is not extractable from anywhere. So if you check in the previous question, again if you try out figure out the same part, then B, you can delete B, D, C and A. So the remaining part is EH. Okay. So EH has to be the part of the key because it is not present at the right hand side. Everything that is present on the right hand side can be extracted from the left hand side. Okay, that is clear. But if EH is not present in the right hand side, how can you extract it? You can only extract it when this is a part of the key. When this is the part of the key. So if you're seeing here this gate question that is asked in 5, you can answer this question in 2 seconds. In 2 seconds. Okay, so check. Is EH a part of the key in A? No, cancel it. Is EH a part of the key in B? No, cancel it. Is EH a part of the key? Yes, yes, but here EH is not a part of the key, you delete it. The remaining answer is D. Similarly, if you take a look at this gate 14 question again, it can be solved in 1 or 2 seconds. Okay, so E, F, H has to be a part of the key. So the confusion will be between these two options. Okay, so just take the closure of it. It will hardly take 30 seconds. You can easily solve it. Okay, so this is the trick that I want to tell you, and this trick can be only visible if you solve around 100 to 100 questions. Okay, so that is what I am telling you by experience. Okay, so
Can
this
you please
particular
repeat
thing
it
is not
once?
written in any book. So I'm able to tell you because I've solved many questions. If again I'm telling you that if you solve many questions, you will be uncover many hidden patterns anywhere.
Excuse, sir.
That is why I always stress on doing more and more questions. Okay, there are some examples. We also try some other questions also. So another question that I have prepared to different combinations with it. So firstly, very simple question: A, B, C, D, E. Uh, the FD that are given to you is AB tends to C, C tends to D, and B tends to E. Okay, so other question, many other questions are also given in your PPT. Have a look at it. I am doing different questions here because you will get a vast practice set. That is why I'm doing a different questions here. Okay, so now tell me which is the candidate key here. Now, there are no options are given to you, so you have to try all the combinations that are available. Okay, so I'll again tell you how to reduce the combination, but try it first time. Tell me the answer in this case, which is the candidate key. Okay, Pranay, I'll repeat it. The same concept. Okay. So the concept is that whatever is present on the right hand side is extractable from the left hand side. Okay. So whatever is present on the right hand side, just delete that from the relation. Okay. So CD is deleted from the relation. The only components or only attributes that is left here is AB. Now AB will always be the part of the key, whatever you are extracting, part of the key. Maybe AB is a candidate key or not. It can also happen that AB is not a candidate key. But this has to be the part of the key. Why? Because it is not present on the right hand side. If AB is not present on the right hand side, how can you extract it? Okay. So if I say CD plus, you will only get CD. Any other thing? No, you will not get any other thing. Okay. So how can you get AB? If I say AB plus, only then I can get AB here. Okay. So this is the main concept here. Okay. So only then you can get the AB. Now you check AB. If you see here the same trick that I have told you, you just delete whatever is present on the right hand side from the relation. Whatever is remaining has to be the part of the key. Okay, so it is not applicable everywhere. Okay, so mostly it is applicable, but sometimes what is happened that everything is deleted. Okay, so I'll tell you. If you go in the previous question, this one question. So if you see here, B is present on the right hand side, C is present on the right hand side, D is present on the A is also present. Okay, so I cannot comment on whichever be the part of the key. Anything can be a part of the tree. Then you have to go to the traditional method. Okay, so keep that in mind that it is not applicable to all. So most of the time this method is applicable. Okay, so keep that in mind. Again, if any doubt, let me know, or just Post a message in chat box if you don't understand. Okay. Now, if you see here, AB plus has to be the part of the key. If it becomes a candidate key, there is no other combination that will be available to you. Why? Because AB has to be the part of the key. If I try any other combination like ABC, it will become a super key. Okay. So now first try AB. AB plus will be AB. Then you will get a E from here. Yeah. And AB, you also get a C from here, and then you get a D from here. So it is able to extract out all the table. Now AB becomes your candidate key. Now there will be no other candidate key in the table because AB has to be the part of the key because it is not extractable. It is not extractable. Only way it can be extractable when it is a part of the key. So if it be AB is already a candidate key. So if it becomes a part of the key, then it means that everything that is adding with the attribute, it will become a super key. So there is no other candidate key in there. Okay. So I'll give you one question. There are more than one candidate key. Okay. So let's check this question. A, B, C, D. AB tends to CD and D tends to A. Take a look at this and tell me what will be the answer here. Yes, absolutely correct. Any other? Okay. So again, if you're seeing here, C, D, A. So B has to be the part of the key. Okay. So if you take the B closure, I don't think you can get anything except B. Okay. So now you have to try different combination, but that combination will always include B. Okay. You can try AB, BC, BD. I think that are the combination of two length that is possible. AB, BC, BD, or yeah. Okay, so B has to be a part of the key. I cannot do anything. So if you take AB, it will extract out CD. Okay, so AB is a key here. There is no problem in that. If I take BC, BC will get BC and no other thing. Okay, so BC cannot be a key. Check BD, BD, D can get A and AB can get CD. Okay, AB can get CD. So ABCD is also in there. So the key will be AB and BD. Okay. So I think you are getting my point here. Similarly, if you try this question again, it will be more than one candidate key here. I'll also tell you how to reduce the effort in this one. Just let me get a bigger question there. Okay. Just solve this question. AB tends to CD, C tends to A, D tends to B. Okay. Try this one. Tell me what are the keys here. Okay, so only one student has given the answer. That is absolutely correct. Okay, so the keys will be A, B, C, D, B, C, and A, D. Okay, so one more question. That is a big question. Now, in this question, I will tell you a little bit of a trick that further reduces your effort. Okay, so try to solve this question. It's not that big, but easily you can solve it. Okay, so A, B, C, D, E. A tends to BC, and then CD tends to E. Now B tends to D and E tends to E. Now if you see here, the method is not applicable here because BC is there on the right hand side, E is there on the right hand side, D is there on the right hand side, A is there. So you have to apply the traditional approach here. So by traditional approach, first you go one length, then you go two length, then you go three length, then you go four length. Okay. So I'll tell you that how can you significantly reduce this effort also, but try first yourself. I will tell you one more trick. Okay, so A is the correct answer, but there will be more than one candidate key here. Okay, also try all the possible combinations. Okay, so I'll tell you a little bit of a trick to solve this question. So first try all the one length possible combinations. Okay, so when you try the possible combination, you will get first A plus. Now A plus will be A, B, C, and you will from B you can get D. So CD is already there, so you can get E from E. I think all A, B, C, D, E. Yeah. So A becomes your candidate key. That is fine. Now try with B plus. Okay. So whenever you are doing with B plus, what you try to do, if B plus is able to, A is already a candidate key. Okay, so B plus is able to extract out A, you can directly say it will be extractable. All the things will be extractable. Okay. So your next step will be that to extract A, if any other attribute is extracting A, it means it is extracting candidate key. So it means all the components can be extracted. Okay. So B is tending towards D, and D uh, I don't think I can get any other thing. Is this possible? Yeah, there is nothing there. So you cannot get anything from B. Now try with C plus. What is C plus here? So I don't think anything you can get from C. So it is also not possible from C. So you try D plus. What is D plus here? I don't think you can get any other thing from D as well. So D is also not there. Now only thing that is remaining is E plus. Okay. So from E you are getting A. So there is no need to check, everything will be already there. Okay. So from E you are getting A. A is already a candidate key. It means that if any other attribute is deriving a candidate key, it means everything is derivable. So you can directly say it is a candidate key. Now, if any other combination, any other attribute is deriving either A or E, you can say that it is a candidate key. It's as simple as that. Now, for two length, what you do, you try those combination which are not successful here. So if you're seeing here, B, C, D are not successful, they are not key. So you try the combination that occurs between B, C, D. Because if you try the combination that is having A and E in it, it will become a super key. So again, you are reducing the effort further. Now for two length, the possible combination will be BC, CD, BD. I don't think you can get any other combination. Okay, so check for BC. BC is getting BCD. Now CD is getting E. E is already a candidate key. You can say BC is also a candidate key now. Okay. So similarly, check for CD. CD is getting E. E is already a candidate key. You can directly say it is also a candidate key. Check for BD here. BD. Now I don't think you can get any other thing. Okay. So the left hand side, no. Okay. So the only thing now that is not successful here is BD. Now can I get a 3 length string that does not contain anything here? Can you get a 3 length string? So I can get BDA. No, I cannot get BDA because A is already a candidate key. It will become a super key. Can I get BDC? Okay, but CD is again present here, so I cannot write C here. Can I write AB here? B is already there. A, C, D. Now, can I write E here? I cannot write E because it is already a candidate key, so it will become a super key. Any other combination? A, B, C. C cannot be there. D, E, no. I don't think there is any 3 length combination possible there. Now you can think that there will also not be any 4 length combination because 4 length combination will again contain the same thing. So if you're not able to get any 3 length combination, you will not be able to get any 4 length combination. So you can directly say the answer will be A comma E, then there is BC, then there is CD. Okay, so these are the 4 candidate keys here. So what is the actual method? Okay, so if everything is cancelled here, like in this case, you are not getting anything. Okay, so you have to try the traditional approach. First go with 1 length, then 2 length, then 3 length, then 4 length, then 5 length, whatever you get. Okay, so if you are able to get anything in 1 length, it means many combinations will be deleted from the 2 length. So that is why I've told you this one. Okay, so in order to reduce your effort, you can go for, like, if you already extracted out a candidate key, if any other attribute is getting the candidate key, you can directly say it is a candidate key. Okay, so suppose in this case E is extracting A, which is already a candidate key. So if you check it will again get out all the things here. Okay, so write A, E, then you will get BC from here, and then you get D from here, and then you get everything from. Okay, so if you're seeing here, if any other attribute is accepting a candidate key, that is already, you have already done, then you can directly say it is a candidate. So it becomes, it again further reduces your effort. Now the second length will be, you do not need to try all the combination, only the failed combination that you get in the first length, you try all those combination, because if you take A and E within those combination, it will become a super key. Okay, so again, this further reduces your effort a little bit. Okay, so these are the patterns that you will observe if you solve more and more questions. Okay, any doubt till here, because it is a very important part. Without it, you will not be able to get the normalization. Any doubt till here? Okay, so we will discuss the normalization in the next part. Any doubt, you know what to do. Thank you for listening. You can move on.